Good morning, class. I wanted to go through a demo of wiring a breadboard using Tinkercad because I finished grading the Chapter 4 Lab for Activity 2 breadboard wiring, and the scores were not very good. And as I was grading and evaluating the work that was being done, I thought that there was maybe a problem with just the overall idea of how to wire a breadboard, especially via Tinkercad. So I wanted to go through this demo so that you could maybe fix some of your errors. I also want to and am going to open up that assignment, lab for activity 2 breadboard wiring, so that you can fix your grade. So if you got a score on that lab activity that you want to improve, you want to resubmit something, then you can resubmit it, hopefully after learning a little bit more from this demo, and we'll wipe your earlier grade and replace it with the new grade. Okay? All right. So first of all, the wiring of the breadboard, let's just start with the basics. You're going to need a breadboard, right? And in Tinkercad, the small breadboard is usually sufficient. They have other ones. They have if I go up here to components and go to all, they have a small breadboard. Let's see, where is it? There we go. So they have a large breadboard, which is here. Okay. And then they also have a mini breadboard, which I'll zoom out a little bit and show you over here. Okay. Now, all of these basically have the same features. The mini breadboard does not have the power rails, all right, but you can see the large breadboard does. But really, for the majority of the work, the small breadboard, the first one that I put in there, is sufficient. So I'm going to delete these two, okay? And then I'm going to bring this in. Now, I find that it's helpful to reorient this. You know, it has numbering or lettering across here. So if I go up to rotate, I can rotate this. So it's a little bit easier to read and to see and to, put things in there. The next thing that you're going to want to bring in is a power source. Okay. Now, for much of the work, we've been using a variable power supply, okay? But for some of the work, we were using batteries. So I know that you're familiar with these because we've been using them, okay? So I'm going to stick with the variable power supply just for the sake of this demo, okay? Nothing will change because of that, all right? Now, the next thing that we might want to do is, or that we're probably going to have in here, is a resistor. So let me go ahead and bring in a resistor. And with the resistor, remember that we need to set the resistance, okay? So these are like the minimal components. I guess we might bring in a push button too, okay? So these are kind of the minimal components that we would need, and especially with the lab for activity 2 that you were working on. We had more resistors, but we can just copy those, okay? So I guess the next step that we want to do is we want to try to address the idea of, okay, so how do we follow a schematic and wire it properly on the breadboard? So for the sake of this demo, I'm going to use this schematic, okay, just as a demo schematic. So we can see in here we have a 12 volt power supply, which we can achieve with the variable power supply. We can set that to 12. And then we have 3 1 kilo ohm resistors. These are connected in series, okay, and that completes the circuit. Then you can also see up here that we have a voltmeter, and the voltmeter is attached across the second resistor in the middle, all right? Now, for the sake of wiring a schematic, all right, wire the schematic without any meters to start with, okay? Remember that meters are not really part of the schematic. They're not part of the wiring diagram, okay? The meters are ways for us to measure and to check different features of the schematic or of the circuit, but they're, technically speaking, they're not part of the circuit in that they're going to be wired into the circuit, forever and amen. I suppose there are some circuits that do have meters wired into them, but that's not what we're talking about here. All right, so what I'm going to wire is this circuit to start with. Okay, so I need three 1 kilo ohm resistors, and I'll set the power supply to 12. All right, so let me stretch that across here. So I'll click on the resistor. Oh, and it's already set to 1 kilo ohm. Now I want to copy it, so I'm just going to do a Control C and then a Control V and another Control V. So I have 3 up there. All right. So let me do something here. Let me kind of minimize this a little bit so I can slide that in there. So I'm going to bring this across here, because what I'd like to do is I'd like to put both the diagram and the circuit together. Okay, so I can almost get it in there. There we go. Okay, so now you can see this as I'm working. All right. So the first thing I want to do when I'm wiring a breadboard is I want to power the breadboard. Okay, and we use the power rails for that. You don't have to use the power rails, but the power rails are intended for that use, and it's much more convenient that way. We want to make sure that we understand and use the polarity of the power supply. So here we have the positive lead, and here is the negative lead for the power supply. So those, of course, will be connected to the positive and negative sides of the power rail. So I'm going to come out here and draw my little wires like so. Now, it certainly is not required, but it sure does help to keep your wiring nice and neat. Okay. Now I'm going to wire, this is the positive lead, so I'm going to keep that wire red. All right. Again, coloring is not important, but it certainly helps, especially when you get into more complex schematics. Now let's connect the negative up here. So we'll just wire this like so. And you'll notice you get these little helper lines, the blue lines that kind of tell you when things are horizontal and vertical. And then I'm going to keep that black. All right, so now I have the power supply connected to the power rail. So I have power to the breadboard. And while I'm here, I'll go ahead and change this to 12 volts. Okay. Now I want to put in these resistors. And the way that I can do that on the breadboard is I can just drop them in like this. Okay, so I saw in some of your circuits, actually a lot of the breadboard wiring that you're doing, you had the resistors wired off the breadboard, and that really doesn't make any sense. So we don't want to do that. So I'm just going to put the resistor here, first resistor. I'll put the second resistor here, and I'll put the third resistor here. So what I'm going to try to do is I'm going to try to stay on the left side. Now, keep in mind, wiring this, there's a lot of variability. There's a lot of different options for this, okay? Resistors do not have polarity, so I don't have to worry about the positive end or the negative end or the anode or the cathode end of the resistor, okay? And there's no button in this circuit, so I don't have to put that in there. But now I want to kind of trace out the wiring on the schematic. So this is the positive end of the battery, right? So the positive end of the battery is going to attach to one side of the first resistor. So here's where I go from the positive end of the battery to the first end of the resistor. Now notice how I'm attaching the power rail to this row. So what in effect, this is row 4, right? Row 4 is all connected to this terminal 2 of the resistor. Okay. Now, the opposite end of the first resistor is connected to the first end of resistor 2. So I want to connect that, and now I can choose any of these, right? So maybe I want to be clear, maybe I want to choose this to this, okay? Now, in this case, let me go back here. Let me change this to red because that's picking up off the power. I'll keep this as green just so I can see a difference because this is connecting terminal 1, in this case, to terminal 2, all right? And then we do the same thing from the second resistor to the third resistor. We can go from here to here. Now, one of the things that I saw in a lot of, practically all of your breadboard wiring was this connecting of multiple wires into the into the same hole. Okay, so this is a very bad practice in actual breadboard wiring. You never want to do this. Okay, and so of course we want to follow the same practice with our Tinkercad breadboard. So what that means is we don't put a let me show you an example. We wouldn't put a resistor and a wire from here to here. Okay, where in this case right here, I have a wire and a resistor going into the same hole, okay? Nor would I want to attach two wires. Let me see if I can get it in there. Two wires into the same hole, okay? That's also bad. So we don't want to do that. And some of you lost points on that, and that's why you lost points. We don't want to do that. That's very bad breadboard practice, okay? So now I have my resistors connected in series, and I want to bring it back around. So the end of resistor 3 is going to connect to the negative supply, the negative side of the power supply. So here is that resistor, and maintaining that same example that I used up here, I'm going to connect from column A to the negative rail, and I'm going to make that black so I can visually see that that's the power, the negative side. All right, so there is my circuit wired properly on the breadboard using, good practice and, following the rules for breadboard wiring. Now, attaching the voltmeter. All right, so first let's bring in a voltmeter. Where are they? They're right down here, okay? So there's my voltmeter. And I'll move this to the side a little bit. It's already set up to voltage, to measure voltage. So let's move this over here. And notice the voltmeter and the ammeter and the resistance meter, or this meter, these multimeters are all marked positive and negative. So we have to obey the polarity on these, okay? And we can see in this is the positive side of the voltmeter, and it's attached to the positive, what in effect is the wire coming from the positive side of the power in between resistor 1 and resistor 2. So let's go ahead. Here's resistor 1, here's resistor 2. So where is in between those two? Well, it's in effect, it's either this line right here, and so I'll pick that up right here. I'll show you there's a couple of options here. So it's either this line right here, and I'm going to color this orange. It's either that line, or we could also pick it up off of here. And I'll put it right here. And I'll also connect it right there. Okay, now, let me first say, that is very bad. We don't need both of these. You do not need the orange or the blue and the blue wire. All right. I'm just showing you either of these are correct. Okay. Either of these are correct because that connects to this side of the resistor or this side of the resistor, which in effect is right there on the schematic. Okay. Now I'm going to use, I'll use I'll use the orange one since that was the first one I did in there. Okay. So there we go. Now notice, see how I have, because of my spacing, I have a lot of connections that I could put in there, right? I still have two more connections, right, that I could make in there. I don't have any more. Now, where does the opposite side of the voltmeter goes? Well, on the other side of resistor 2. So I can come over here and let's see, that's going to be right here. Now I like, because I'm coming in at an angle, I like to come in like that. Let's go a little bit below. Here's a little, and I'll show you a little trick here. I'll make this one blue, okay, just for variation. All right, so now if I was to share this Tinkercad breadboard with somebody, it would be confusing right here, right? I have wires crossing other wires, and so it's kind of hard to see. Oh, does the blue one stop there? Does it stop there? What's going on here? So we want to make sure that we have a clean breadboard. So in this case, what I'm going to do is I'm going to introduce a bend in my wire, okay? To do that, I can double click on the wire and I can introduce that little bend. So now what I'm going to do is I'm actually going to come all the way down here, and I know this seems like a lot, but you know, it actually is going to be fine, and pull that like that, okay? So now I have my voltmeter wired correctly in over or around the second resistor right there, maintaining polarity. And when we run the simulation, we should be able to see, you know, 4 volts, which is correct. All right, we have a 12-volt power supply, pulling that in there. All right. So, so that's kind of a little detail about the wiring a breadboard on Tinkercad. Let me do, just real quick, let me do another more complex one. So I pulled this up here. Let me squeeze this over and give myself a little bit more room there. All right, so you can see on this one, now we have a switch. We've added a button, okay? And we have 3 resistors again. All 3 of them are 1 kilo ohm, but we have them connected in parallel. All right, and then we have a resistance meter across the second one. All right, so how would I wire this one up? All right, so let's get rid of, I'm going to pull these resistors off because I am going to use them, but I just don't want them in that configuration. I'm going to leave the power supply on because that's all good. I'll get rid of this, and then all the wiring. Okay. And I'll change this to a resistance meter while I'm remembering about it. All right, so again, remember the rule. First of all, wire the schematic just following the lines of the wires, right? So the positive side of the 12-volt power supply is connected to one side of the switch. All right, ignore the meters and add them after you finish the schematic. Okay, because they're technically just there to measure portions of the schematic, all right, or of the circuit, I should say. All right, so here's our button, right? We're going to use the push button for this, even though this is technically not a push button, it's a switch. If you really wanted to be accurate on this, we would use, let's see, where is it? Right there, the slide switch. That would work with that. Okay, but we'll stick with the push button. So the thing with the push button is it has 2 sides. All right, one side here, terminal 1A and terminal 2A, are working together, and the other side, terminal 1B and terminal 2B, are working together. So we can actually have the push button control 2 different circuit lines, I suppose. I'm going to rotate this because the way I have this configured, the breadboard, I want to use it like that. All right. So now I want to drop the push button in. And in this configuration, I can use the push button to span that spine, that middle section here. And I'm not going to worry about the right-hand side. So the terminal 1B and terminal 2B, I'm not even going to use those. I just need to use terminal 1A and terminal 2A. All right. So there's my push button. Now I want to connect the positive side to the first side of the switch. So I'm going to connect that right there, and I'll make that red so I know that's picking up power. And then the switch is going to come off here and go to the other side. All right. So for the resistors. Now I have resistor 1, resistor 2, resistor 3 in series in this case. So I'm going to put one here, one here, and one here. Okay. So now let's trace the line. So from the switch, it's going to go to resistor 1. All right. So from the switch, and I'll just, these will be, this is resistor 1, this is 2, and this is 3. So from the switch, it's going to resistor 1. Okay. Oh, wait a second. From the switch, it's also going to resistor 2. Oh, okay. So I'll pick up that from that row and go down to resistor 2. Okay. Let's change that color. Let's make that a yellow just so it stands out a little bit more. And then, oh, wait a second. Look at that. From the switch, it's also going to resistor 3. Oh, okay. So now, so this is an example of how we can wire in parallel, right? So now we have these 3 connected, right? Notice that each end of the resistor goes to the negative power supply. So now I can go look, this whole row is that end, connected to the negative side of the power supply. So this whole row, so I'm going to drop that right there, and I'll change that to black. I'm going to drop that right there, and I'll change that to black. And I'm going to drop that right there, and I'm going to change that to black. All right, so there is our circuit, correctly wired, all nice and neat, right? We have different coloring so that we can pick up the different sections of the schematic. Everything is connected to the power supply. Now, the only thing I need to do is connect the resistance meter. And you can see the resistance meter is connected across the second resistor, the middle resistor in this parallel circuit here. So that's this one right here. And we got the wires right there. So I'm going to, now this is going to be a little bit tricky to get in there. So I'm going to go like this. I'm going to bring this over here because I love having this nice and neatly organized. You should too. And here's the second one. So this is going to be on the positive side of this. And we'll change that to red. And this will be the negative side of this. So actually, because I already have that one there, I'm going to come off at an angle here. So I'll go like this. Because again, I want to make it clear if somebody's going to be reading my Tinkercad, connections, breadboard, I want to make it clear how that works. Okay. And so there we go. All right. So now I have this completely wired correctly, following good practices, principles, and rules for that. I can start the simulation and see what happens. We get 333 ohms to start with, and then I press the button and we get an error, which is what we're going to get on this. So this is wired correctly. Okay. All right. So there you go. Those are some examples. I hope that helps. Like I said, we will reopen the lab activity 2, lab 4 activity 2 for you to resubmit if you are not happy with your grade. And in fact, if you want to resubmit any of the work that you did after that with a breadboard because of this new information, if you want to fix your diagrams, please do so. Okay, we won't count them late. Just resubmit it, and then I'll redo the grade. Now, just so that I know, I know when the deadline is for this, I will put a deadline in for the resubmissions so that it isn't something that takes all semester to do that. But I'll try to give you a very reasonable time for fixing that. So that you can understand and better apply the breadboarding principles in Tinkercad. All right, if you have any questions, please email me, let me know. All right, thanks, bye.